In this problem, a landscaper wants to surround a garden that measures 3 feet by 5 feet with a gravel border of width x. We are asked to write an equation for the area of the garden and border. Let's try to write an equation for the dimensions of this larger rectangle. Let's first look at the width of this rectangle. When we look at the horizontal side here, we start with a base of 3 for our width. And on the left and right, we're going to add x onto it. We don't know how big x is, but we must add 2 of them. Therefore, we can say our width will equal 3 plus 2x. We can look at the length the same way. The length begins with a base of 5, but then we'll add 2 more x's onto it, 1 on top, 1 on the bottom. Therefore, we'll say L is equal to 5 plus 2x. Now that we have the dimensions, let's think about area. Since this is a rectangle, we'll say that the area of a rectangle is equal to length times width. We know the length is 5 plus 2x, and we know the width is 3 plus 2x. So we'll replace L with 5 plus 2x and replace W with 3 plus 2x. Then we multiply them together. When we multiply, we'll take 5 times 3 for 15, 5 times 2x for 10x, 2x times 3 for 6x, and 2x times 2x for 4x squared. Then we combine our like terms. Our area will then equal 4x squared plus 10x plus 6x is 16x plus 15. This will be our polynomial model for the area of this garden. Part B says, if the landscaper wants the total area to be 35 square feet, how wide will the border be? Now we go to our area equation, but we let the area equal 35. We replace the letter A with 35. Therefore, we say 35 equals 4x squared plus 16x plus 15. We now subtract 35 from both sides because this is a second power equation. This will give us 0 on the left. This will give us 4x squared plus 16x minus 20 on the right. We could try factoring now, but to simplify our math, let's divide everything by 4. Since all of our numbers are divisible by 4, this could give us something factorable. When we divide, we'll get x squared plus 4x minus 5. If we try to factor this, we can think of two numbers that multiply to negative 5. If we try negative 5 and positive 1 and add them together, we would get negative 4. That's the right number, but the wrong sign. We want positive 4. Therefore, we'll use 5 minus 1 instead. So, the terms we factor into will be x plus 5 and x minus 1. If we split this into two pieces, we'll have x plus 5 equals 0 and x minus 1 equals 0. If we solve the x plus 5 equals 0, we'll end up with x equals negative 5. However, in a real-world problem, we cannot have negative distance. Therefore, this is a fake solution. We must use only positive numbers when we're dealing with real-world objects. If we solve the other piece, we'll move the 1 to the right and say x equals 1. Therefore, the width of our border will be 1 foot. And this is how we use our polynomial model for area to figure out how big the border must be.